about the y-axis. And then ask for its volume. The volume of this shell is approximately 2 pi r h delta x. Just that one element. Of course, I'll have to add them all up. Get a sum. Let delta x go to 0, get an integral. So here's my shell. I need to identify these things. Well, everybody knows what pi is. It's the number about 3.14. It's true. What is my r here? What is the radius of the inner shell? Huh? Sorry? Or you can just draw it. This is the radius. R. This is the outer radius. R plus delta x. This is the height. What is the radius? It is where you are. X. And of course, this is delta x being thickness, kind of small. What is the height? Huh? The height at x. Put the x into the function. Multiply by thickness and add them all up. You will get an approximation to that volume. How will you get the exact answer? You will let delta x go to 0. As you say, you will pick up an integral. From where to where? And that is how you will find the volume under the area of the curve. F of x between a and b, when you rotate that about the y-axis. Put your pen down. In order to find the volume of this thing, that is your stadium, which is the area shaded under f of x between a and b, rotated about the y-axis, you will have to take that function multiplied by x, multiplied by 2 pi, find its antiderivative, evaluate it at b, evaluate it at a, and subtract. Which is to say, now you set it up as a calculus one problem. Again, if you want to find the volume under the function f between a and b, created by the object when you rotate that curve about the y-axis, you will have to take that function, multiplied by x, get another function, multiplied by 2 pi, get another function, find its antiderivative, evaluate it at b, evaluate it at a, you will have your exact answer. But it becomes now a matter of finding an antiderivative. And if you do not know how to find the antiderivative, you will have to do a numerical approximation of the trapezoidal rule or its Simpson's rule. Which is why we studied that. Let's take a look at an example. curve, 1 over 1 plus x squared. And I want to look at that curve between x equals 1 and x equals to 3. I want to rotate that curve about the y-axis. Find the volume of the solid thus generated. Exactly. You can make a little sketch here. But we're going to set it up as an integration problem. That is an area problem. Even though we are finding volumes. So I'll make a little sketch. I don't know what this function looks like, but let's do something like that. Between 1 and 3. We're going to take this thing here and rotate it. Oh, by the way, you can see that this is a strange integral. It's got nothing to do with the radius squared, which is what you did when you rotated about this way. You had pi f of x squared. Which gives you pause if you say, let's change x's to y's and try to do it by rotating about the x-axis. Why is it like this when you rotate about the y-axis? Why is it not radius squared? That will give you pause when you try to say, let's change everything to x's and y's and try to rotate about the x-axis. This is part of the reason why it's hard. Okay, so we're going to rotate about here. I'm going to create a volume. I'm going to create a volcano. How much lava is left in the volcano after it's been shot out? So, we say to ourselves, we've got to set this integral up. We'll integrate from where to where? 1 to 3. 2 pi x f of x being what?
1 over 1 plus x squared.
Which is no another function. You're not integrating 1 over 1 plus x squared. You're integrating x over 1 plus x squared. Because of this thing here. dx. And now you may do what, Mr. Tyler?
I mean,
You will give it to your calculus 1 friend. Your calculus 1 friend is an expert at finding antiderivatives. What is the antiderivative of this?
well, that would have been 1 over
Miss Heather, what is the antiderivative of this, Miss Heather? What do you think the antiderivative of this is, Miss Heather? Something different. My point is x is multiplying it. Obviously different integral. Okay? Be careful. There's an x multiplying f. You're not integrating f. You're not integrating x f of x. It is something different. Please. Be aware of this. Okay, you must know how to, the meaning of this. Yes, Miss Heather, this is correct. The antiderivative of this is the inverse tangent of x. Let's see, what is the antiderivative of this?
1/2 ln of 1.
You have to do a little u substitution, huh? The point being, that is the calculus 1 problem. How do you find antiderivatives? Calculus 2 is setting up this integral. Yes, so you do a little u substitution. Yeah. In fact, I think we did this one. Early last semester. Yeah.
Maybe.
Most certainly.
1/2 ln 1 plus 2.
Most
plus
of
six.
We've done this one before. So I want the antiderivative of this. We'll say that u be 1 plus x squared, and du by dx is 2x, and so x is equal to over 2x. This will come here, you know this is an x, this will be du, and this will be dx, this will be du over 2x, and x will cancel that way. It will be 1 over 2, 1 over u to u, which is 1/2 ln du, which is 1/2 ln 1 plus x squared. Yes, so